and welcome to this program for Design and Technology. In this lesson, we are going to look at a very important aspect of ergonomics, which is called anthropometrics. We will look at the definition of anthropometrics and how to apply anthropometric data to design problems. And in this case, we will look at handle design. To start, let me ask you a question. What if all lady shoes were made to the size of Cinderella's feet? The answer to that is, one size does not fit all. As you see, humans vary significantly in size and build. The study of human dimensions is called anthropometrics. Anthropo for human and metrics for dimensions. Whose dimensions now? Only adults? No. If you have a look at babies' books, you will agree that they are generally made small. The pages are also thick so that babies can easily handle them. Babies' books are made suited to their hands, of course, and not to the hands of adults. In some situations, it is fine if we just design for the smallest or largest likely dimension. In other situations, adjustable benches, chairs, or devices are required for the full range of people. Some chairs and tables have locks to allow them to be easily adapted to befit the height of people using them. If an artifact is adjustable, it can fit to anyone. Now, if the dimensions of objects must be suited to the dimensions of users, which are the dimensions that we need? As we said, the study of human dimensions is called anthropometrics. The definition of anthropometrics is: anthropometrics is a field of study of ergonomics related to the sizes and dimensions of human beings. How then do we relate human dimensions to products? We'll have a look at an example in a hairdryer. The illustration shows two anthropometric data that are important when designing the hairdryer. Handle size should be according to size A so that it easily fits the hand. Buttons should be within the reach of and easily operated by fingers. The kitchen furniture you see here needs some handles. Let us see together which types of handles would be most appropriate. A multitude of different handles are available in stores, and these can be sometimes too small, too stiff, sharp, awkwardly placed and confusing to use, or just right. Which ones do we choose? What are the criteria? To design handles, we first study the types of hand grips. Objects can be held in different types of grips, namely the power grip, the pinch grip, external precision grip, and the internal precision grip. Every well-designed product must be easy to use, comfortable, and safe. A designer who is working on a handle needs to consider the following issues. Is the handle wide enough to hold without being too wide to grip and could slide out of the hand? Or is it too narrow so that it cuts into the fingers and cuts off the blood supply? Or is it just right so that the user can get a good firm grip and hold it comfortably and safely? Is the length of the handle long enough to allow all 4 fingers to fit into them without squashing them? Or is it too long so that the hand can slide to one end and not hold the object level? Or is it just right so that the fingers fit without being squashed and the handle ends stop any sliding? If the handle has to be long, then sliding can be stopped by using a slip-resistant material such as soft rubber, or by shaping the handle. Do you remember the handle of the travel cup we had analyzed in the first video? The diagram shows the measurements that would be taken for the average width of a hand. How will the data help me design? Once A, the average width of the hand, and B, the maximum handle size is worked out, the handle can be designed to fit this measurement. To be more specific, some of the main dimensions of hands are hand breadth, finger length, knuckle length, and thumb length. These data can be measured and tabulated for several people of different ages, both female and male, and then be used for the manufacture of artifacts suited as per age group. Finger movement, positions of grips, maximum dimensions of objects that can be grasped are also recorded and used. Then, does this allow us to choose our handle? We will see that the final choice depends also on the force required. Light drawers or easily opened doors might be opened with only one finger or perhaps 2. For example, here we have a few finger handles that can be opened with 2 fingers easily. Other doors and drawers might need more force and therefore must be opened with the whole hand. Longer handles are required where larger forces are needed, for example, for large doors or very heavy drawers. In this case, at least double the clearance is required so that both hands fit onto the handle. The study of grips and hand sizes have led to some good adaptations of tools and handles. These handles make the tools easier to use and hold. Other ingenious designs are the designs of children's writing aid grips. The study of ergonomics, measuring and recording of average children's hand sizes and the correct finger position while writing, enabled the fabrication of this product that really facilitates the process of learning to write for younger children. Maximizing the contact area with the palm and fingers has improved grip and reduced slipping in this simple kitchen tool. So in this lesson, we have seen the definition of anthropometrics, how to denote and specify anthropometric data, and also how to apply anthropometric data to design problems. We looked at handle selection and how to relate it to anthropometrics. This brings us to the end of this presentation. Our next topic will be Anthropometrics in chair design. Don't miss it. See you soon.